Hello everyone, this is the professor, and this is the introduction to trigonometry. Now today we're going to talk about angles and their measurements. Now let's just start with the ray or the half line. It is a portion of a line and extends indefinitely in one direction. As you notice here, V is the vertex or the initial point there where the ray will start. And it will go this way in this direction, or it can even go in this way in this direction, forming an angle. Now, if two rays are drawn, in this case, yes, with a common vertex, they form an angle, just like right here, like so. And we call one ray of the angle the initial side, and the other the terminal side. That's very, very, very important. Now, if the rotation is in counterclockwise direction, the angle is positive. And if the rotation is clockwise, the angle is negative. Now observe these Greek letters here, alpha, beta, and gamma, which basically denotes the angle here in each of the angles that are specified on the board here. However, let's look at this a second. If you notice, there are two rays. The two rays are drawn. This is a ray and this is a ray. And then we talked about the initial side here and also the terminal side here. And as you notice that this is going in a what? A counterclockwise motion this way. And the counterclockwise rotation denotes a what? A positive. This is alpha as being a positive angle. Do you see this? Okay. Counterclockwise and clockwise motion, if you have a clock on the wall, and the clock, of course, if you, and I'll just show this very quickly, you have 12, you have 3, 9 o'clock, and 6 o'clock, basically. And you have two hands here. Let's say this is at 3 o'clock. This is the small hand, this is the big hand. Well, this is going in, traveling, going this way is going in a, what? That's going in a clockwise motion. If, however, by some crazy reasoning or position of the clock, and it decides to go the opposite direction, then this will be a counterclockwise motion, right? Which means in the counterclockwise motion, you still have a positive angle that is be represented when that happens, and then of course, in a clockwise motion, it'll be a negative angle. Yes. So let's go back to our diagrams here. Beta is represented from here. This is the initial side coming from here, circling here, hitting this point. So that's some big angle. And that's a clockwise rotation, which will be, beta will be actually a negative angle. Let's go here. If we start at the initial side, always start at the initial side, always. And then work your way around. This is going in what motion? This is going in a counterclockwise rotation type of motion. And this will give you what? This is a positive angle, believe it or not. Later on, we'll talk about coterminal angles also as well in future videos to come. Now, an angle theta is said to be in standard position if its vertex is at the origin of the rectangle coordinate system. And its initial side coincides with the positive x-axis. Now, look at this. This is the x-axis here represented, and this is the initial side of the angle, and this is going in a counterclockwise motion. This is the terminal side. Theta is in the standard position. So here, again, we're talking about, here, theta is what? Positive. And we'll talk about in just a second, in just a moment, what quadrants these angles or points will lie in. Follow me. The Cartesian coordinate system. Let's review that. Well, we know you're in trigonometry now, but it's always good to review the basics, right? So if we look at this here, if an angle or a point lies in this portion of the graph, Well, let's just talk about, you got the x-axis, you got the y-axis, and you got the quadrants, right? This is said to be what? If anything or any angle or any point lies in this portion, here you have what? This is the first quadrant, and it's positive, right? And these ordered pairs symbolize, for example, here is this x value, and this will be the y value. So this is the x value, and this is the y value, meaning this will be x and this will be y. We will really get into detail of what these are all about. How about if an angle or point lie in this portion of the graph, the system? This will be quadrant number what? 2, which would be what? Negative positive. If we continue to go, this will be quadrant 3, which will be negative, and this will be quadrant 4, which is positive, negative. Now, as we see that, when we get to the unit circle, all this information will be very, very valuable. Now, when an angle, theta, is in standard position, the terminal side will be either in quadrant, or the terminal side will lie on the x-axis or the y-axis. If the terminal side lands in one of those, theta is considered to be a quadrantal angle. And if you look here, let's look at some examples here real quick. As theta lies in the second quadrant, you see this from here. This is the initial side, and this is the terminal side. So this angle will lie in the second quadrant. Let's go here. Same here as well. Now this is going into what? Let's go back for a second. This is going in a counterclockwise motion. So you know that angle is going to be what? That angle is going to be positive. Very good. Very good. So now if we go this way to this angle, particular one, this is going in a what? This is going in a what motion? This is going in a clockwise motion. So clockwise will be what? Will be negative, right? So this theta angle lies in the what? In quadrant number 4. And as we look at this angle here, look at this picture here, this is going here in a counterclockwise motion, and this angle is lying on the right here on the axis here, the y-axis. So this is considered what? Quadrantal. Now remember, this is the initial side, so you draw your line from that point from the initial side to the terminal side, and theta is quadrantal in this case. Well, this will basically end the talk. For just the introductory, we'll do a second part of lesson. Actually, this is lesson 1, and we'll call the next lesson lesson 1A, which we'll get into degrees, minutes, and seconds. We will learn how to convert those things, and also we'll convert pi to radians and radians to pi. So stay tuned for the next video, and I'll see everybody later on.